Hello everyone, I am Leslie Jager and today I'll be speaking about should you use Rust. Just a quick confession before we start. I am a Rustacean. I am that annoying person shouting in the background, use Rust, but Rust, Rust. Naturally my tech lead is not very happy with me. However, today's talk is to show you why you should consider Rust more often with the software that you write. I have been using Rust for about 3 years and I've got about 5 years experience in software engineering. So we are here today to ask the question, should you use Rust? In one word, yes. In 4 words, yes, but it depends. So what is Rust? What is this mythical language everyone talks about? If we go to Rust's official website, it describes Rust as a language empowering everyone to build reliable and efficient software, with the 3 pillars being performance, reliability, and productivity, and is currently being used often with the CLI, WebAssembly, networking, and embedded. So how long will it take to use software written in Rust? Quick hint, it is a lot simpler than you think. You already are, or someone close to you is at least. Rust is currently being used in production by Linux, with Linux drivers being rewritten in Rust, the Firefox CSS engine, npm, Dropbox, Discord, Android 13 and up, Cloudflare, their DNS server has been rewritten in Rust. Figma, the Windows kernel, is also being rewritten in Rust. AWS Lambda, the Firecracker micro VM, is written in Rust. And for you gamers out there, the Finals is also actually written in Rust. So what are the benefits of Rust? Just a quick disclaimer before we continue. Some of the points I will be emphasizing today can be mitigated using tooling. However, with Rust, the tooling is more or less already built in. So some of the benefits of Rust is performance. It's comparable to C and C++ with a low RAM usage. According to a study done in 2017 for the energy efficiency of multiple languages, Rust is near the top of the list in every category, being energy, time, and memory. However, this was 2017 and Rust has improved significantly since then. Here we have AWS Lambda cold starts. As we can see, Rust is near the top of the list. It has a cold boot time start of 22 milliseconds, 14 megabytes of RAM, and 1.5 milliseconds execution time. This is just a Hello World Lambda, so we can more or less see a clear picture of the cold boot time of all these languages. Concurrency. Rust has a lot of measures in place to prevent issues that can occur with multi-threading. And is very simple as well to spawn a new thread with Rust. As we can see here, it is just calling thread spawn and we spawned a new thread. As simple as that. Some of the keen-eyed among you might have seen move. In this case, we are moving num from the original domain being the main thread to the newly spawned thread, the new domain. Hence, we're moving the value. But it is even simpler to make lists multi-threaded. Here we have just a normal list and we are summing up all the variables within that list. Naturally, if it's very big, it will take a while. However, just using one package, rayon in this case, and replacing iter or iteration with par-iter or parallel iteration, we can boost the performance significantly. And rayon does all the heavy lifting for us. Naturally, security is a big feature of Rust as well. It's a memory-safe language But interestingly enough, there's no garbage collector at all. And the White House even recommends Rust as one of the languages to be used for critical software. And with Rust, it just works. Whatever you can compile in your program, it just works out the box, provided there are no bugs in your code, naturally. However, the compiler, as strict as it is, also prevents weird bugs from occurring and race conditions as well. What you see in the code is what you get. So let's compare some code just to prove a few things. Here we have a normal hash with Python. We're just hashing the contents with MD5. Here we have Rust. As you can see, it is as readable as Python. And just to complete it, here's the C++ variant of this code. A lot more difficult to read compared to the other two. So naturally, code can also improve readability, especially if it is readable. And as we saw, the Rust code is as readable as Python, making it much easier to review PRs as well, due to the code being a lot more readable and understandable. We can also determine if there are errors a lot easier with Rust, preventing software from crashing as a result. According to a study done by Google in 2022, they took C++ developers and trained them in Rust, and Java developers and trained them in Kotlin. And they asked both teams how long it took them to feel productive in the new language that they learnt. Both answered 8 weeks or less. And interestingly enough, the output of the Rust developers was on par as the Kotlin developers and double the C++ developers. But we don't really want to be productive at the cost of sleep. Naturally, we all want sleep, and a well-rested developer is a productive developer. And with Rust, we can ensure a high degree of code quality and stability for the software we write. And not just that, Rust forces us to handle the negative cases. However, naturally we can handle it ourselves, but sometimes we do need tooling to help us with that. And Rust does have some tooling to help us with that in the form of Cargo. Cargo is Rust's package manager. Not just that, it's the build tool as well as the test tool. And the Rust compiler gives us good error messages to determine what the issue is with our code as well, with the rich documentation as well to explain why those errors occur. And Rust also has a growing ecosystem as well, allowing us to develop quicker using packages provided in the ecosystem. However, the ecosystem is not helpful if there is no documentation. With Rust, we can generate documentation from the code itself. And not just that, we can also add unit tests to our documentation. As we can see here, there is a snippet of code for regex to show how to use it. However, it's in the form of a unit test. So if we were ever to change our regex code itself, but we don't update the documentation snippet, it will fail the tests, showing us that it is not in sync with the actual code, forcing us to update the documentation, and as a result, the documentation will be in sync with the code itself. And not just that, there's a lot of tooling that we can help and check our code and validate it. Tooling such as fuzzing, as well to ensure our code quality won't break, as well as property testing, true available in other languages, but with Rust it is already available. Tooling is great and all, but it's only if the syntax is intuitive as well. As we saw, it is readable. But in my opinion, the Rust syntax is the combination of C, JavaScript, and Python producing Rust. However, the offspring has been raised in the army as well, being very strict as a result. So we saw some Rust, but let's take a look at some more. Here we have an example of a book. Naturally, a book has authors, one or more. There are pages in a book, I would hope at least, and possibly a publisher as well. With the first function of the implementation of the book struct, we see new, which is static in this case, because it does not reference the actual value itself. However, the second function, read, we are reading the value itself, so it needs a reference to it. And repair. As some of you might have seen, there's the mute keyword. Rust, by default, the variables are immutable, meaning that we have to specify if we want to change the value itself. Hence the mute keyword. And to repair book, we need to naturally change the state of the book itself. And finally, give. Here we don't have an ampersand as some of the other functions do, meaning we are taking the value itself and not a reference to the value. We are giving the value away, in this case, the book. On the right, in this case, Jack is borrowing the book and he's reading it. Naturally, I do want to allow people to borrow books and read. And then with mend, here we give them permission to be able to change the state of the book to be able to repair the book itself. So naturally, this is simple and all, but we often use APIs and servers in our code. And with Rust, it is as simple just as adding the serde package with serialize and deserialize traits to your data structure. As simple as that, it does all the heavy lifting for you. Naturally, we also want to be able to tell what format we are serializing or deserializing to, but with the Rust, almost all packages use serde, meaning it is one place that this logic is being implemented. And it's as simple as just either using, in this case, serde JSON for the first example, or serde YAML. And we're both reading the string contents in either format and deserializing it to data. It is as simple as that. Naturally, there are a few more amazing aspects of the language itself, and this is what makes me excited about Rust. Firstly, it is statically typed, no duck typing. The typing allows us to prevent issues such as dividing hello world, as an example, by 42. But not just that. Sometimes we don't want to allow certain functionality to be available at the same time. There are features in Rust, similar to feature flags in other languages. However, with Rust, this is done at compile time. So, and not just that, we can use these features to either add or remove functionality based on the architecture that we are compiling for, be it ARM processors, 32-bit, 64-bit, or even WASM. While it is a great feature, pun intended, we can also use object-oriented programming. With traits in Rust, we can have similar functionality. Similar to interfaces and abstract classes, but probably closer to abstract classes. In Rust, we can have default implementations of the functions that we are creating in the trait, and traits can also inherit from other traits. So let's take at a simple use of the traits. Here we have a reference trait, and naturally this reference is just to be able to reference other media. In the first case, we are implementing reference for books, so we want to be able to reference a book. And the second example, we are referencing movies. And in the last one, we are actually using any variable that implements the reference to get that reference for that media itself, allowing us to have something similar to object-oriented programming, but it is not as complete as it would be in Java, as an example. Traits are awesome and stuff, but sometimes we just want to generate it, and that is where macros comes in. Macros can be used to generate traits for us automatically. And not just that, it can also shorten our code itself, allowing the code to be a lot more readable than by doing it by hand. There are two types, declarative and procedural, and we've already seen some examples as well. Here we have just a typical example of a procedural trait, being the builder pattern. We can quite easily add a builder pattern to any struct just by adding the builder pattern package, whichever one it is, and implementing that, adding that trait to the struct itself. As simple as that, is all done at compile time. No more worrying about how to implement it. It just gets implemented automatically, freeing up your time on more important tasks. I personally have used it to be able to create an API client. So naturally, with queries, it is very difficult to determine what query should be sent through in the API call, but with the builder pattern, it made my life so much simpler. Sometimes referencing data in several places can introduce bugs, but with Rust, we have the ownership model to prevent that. So on the left, we've got the code that we saw earlier for the book struct and how we referenced it, and it was mutable in some cases. On the right, we've got the actual example. So as an example, I own a book, and because I can own it, I can change the state. Well, I got the book, so I read the book. After that, I lend it to somebody else, in this case Jack, and he borrows the book and reads it as well. After he is done, I read the book again. I really enjoyed it. However, my favorite book is now a bit more tattered, so I send it into the repair shop and I give them permission to change the state of the book, and they are able to repair it. And after they're done, I've got my new book back, so I read it again. However, now I give the book to Susan, and Susan reads the book. But if I try to read the book, I cannot, because Susan owns the book. I no longer own the book. I can possibly borrow it from Susan, but I don't own it, so I cannot directly read it anymore. This is, in a nutshell, the ownership model in Rust. And typing helps us prevent issues with Rust. And Rust enums is an integral part to the rich type system that Rust provides. Enums can have data embedded in it itself. So similar to unions or in other languages, but it'll probably be a bit easier to refer it as tagged unions. And Rust can also prevent you from forgetting to handle certain enum variants as well. There's exhaustive pattern matching in Rust. Here we've got an example. The enum has 4 variants. However, when I convert it to a word, I've only handled 3. The compiler will complain, telling me I have forgotten to handle this variant of Rust itself. And not just that, we can map certain data structure to enums itself, making it simpler to determine what variant of a data structure we are referencing and using. As an example, here we have 3 responses, all variants of each other. The first, just a title. The second, a title and message. And the third, title and subtitle. However, as we can see, it is being embedded within the enum itself, allowing us to easily and quickly determine if it is the title variant, the message variant, or the subtitle variant. And enums are not just for data, it is also for error handling. With Rust, the errors are an explicit return type, and it's easy to see if a function can fail or not. So if we were ever to call this function as an example, we can see an error can occur as a result. Not like other languages where we can throw exceptions, and if we were to use that function, we would not be aware of it. So here we are opening up a file. The file can exist, but possibly not. It might be already opened by somebody else. Or we don't even have permission to be able to read the file, failing to read the contents of the file itself. With Rust, we can easily see that this function will return an error as a result of it. Pun intended. With Rust, null values are represented as an enum, allowing us to easily see if a value is nullable or not. This is the definition of Rust null values, a simple enum, generic enum. Naturally, it has either some value or no value at all. And with Rust's typing system and ownership model ensures the correctness of the code itself. While yes, the compiler is very strict, and often we say we fight the compiler within the Rustation nation, however, it does prevent a lot of issues that can occur with the borrow checker itself, and it does prevent unexpected surprises from occurring. If I was to give an analogy of Rust's compiler, it is like that very strict driving instructor that we had. Hopefully you as well. The driving instructor will ensure that we understand the rules of the road and how to handle the car properly, ensuring that we are safe and the others on the road as well. However, we could also possibly have a sloppy and maybe even drunk driving instructor. We get away with a lot, but we are not keeping ourselves safe and those on the road as well. So the Rust compiler is the strict driving instructor. And not just that, if we get the approval of the strict driving instructor, we are guaranteed and ensured that we will be able to drive safely on the road. In a similar manner, if Rust compiles, it more or less guarantees it will work and keep the software safe. And sometimes the strictness of a compiler can also help us with simple API calls, as an example. Here's an enum of various errors that can occur. Deserialize, there's error response from the server itself, or some unknown error, such as we don't have internet, as an example. And as we can see in the main function, we are making an API call. And if successful, we can obviously do something with that data, but if unsuccessful, we can match the error to the specific enum, allowing us to quickly and easily determine what type of error occurred, making it a lot simpler. Here we've got the data structure to do with the serialize, deserialize. We make the API call, and sometimes it is successful, but it could possibly fail to deserialize. And if it fails, we return the error. If successful, we return the actual response of the deserialized data. Naturally, here we've also got the response error from the server, and finally some unknown error that can occur. So some of you might have been keen-eyed. Some of the keen-eyed among you might have seen the match against various errors. This is Rust pattern matching. With Rust, it's very similar to a switch statement in other languages, but with Rust, we can go a lot deeper with the pattern matching. Here we've got a simple foo structure with a tuple and a variable, and here we can very easily have the switch statement handle the pattern. Either the first variable in the tuple is 1 and we have that result, or the y value is 2 and we can have the logic being handled in that manner, or we just default to y and we only care about y and not about the x value. So this, in my opinion at least, is a lot more readable than a bunch of if statements. So we've seen how errors are handled. So what about null errors? Here we have an example of just reading on the environment variable home. In the first example, we handle it appropriately. If it exists, we do something with it. If it doesn't exist, well, it doesn't exist. However, we can even set defaults if those values don't exist. In the second example, we're looking for a prod keyword to get the website, but if it doesn't exist, we default to example.com. But The type system only works if the compiler itself is very strict. And as we've seen, and probably some of us have heard, the compiler is very strict. But it also helps us as well. The compiler and traits implemented in Rust ensures that memory management is handled by the compiler, no garbage collector. When the variable is out of scope, it is automatically freed from memory. And not just that, the compiler can check things outside of the code itself as well. Here we have got SQLX making a query to the database, and it's a raw SQL query itself. At compile time, SQLX will take the query and validate it against the database. So if we are pointing to the wrong database, or if the database is structured incorrectly, it will fail to compile. And not just that, if the SQL query is incorrect, that will also fail to compile, meaning the SQL will be ensured it will work at compile time, and we don't have to determine this at runtime. And some of the memory issues that Rust prevents can be seen in this JavaScript example. Here we are just dividing x by 2 to get the result. And naturally, unknown to the user that's calling that function, x is being reassigned with 21. So naturally, I would expect that x is first 20, which it is, and the half of that would be 10, which it is, and I would expect x to be 20 again, but it's 21. The amount of bugs I've had to handle in this manner is quite annoying, to be honest, as well. But with Rust, this can be prevented with the mutability. In the first and third functions, they will fail to compile due to Rust not seeing that mute keyword. These are immutable. I cannot assign a value to it. The second and fourth are mutable, so I can assign value to it. However, if I was to call this function, I will see the mute keyword, informing me that there's a possibility that the data will be changed when calling this function, preventing a lot of issues and bugs to occur in a similar manner. So the compiler prevents us, but only if it is useful to show the issue itself. And the Rust, there's a rich documentation for compiler errors. It shows the compiler errors and how to possibly solve it. Not just that, it gives error codes to show what the error is. And if we were to run this error code in the terminal, it will give us documentation to show how this error occurred and how to fix it, and what prevents the compiler from actually compiling. So less time from pulling out our hair and spending time on Googling on Stack Overflow. So since Rust syntax and tooling helps us so much, there is naturally a reason why it's the most loved language on Stack Overflow. It has been the most loved language for 8 years running. A lot better than most other languages that we use today. And as proof of that as well, the ecosystem in Rust is growing. It's growing at an exponential rate currently. Not just that, it has high quality and stable packages within the ecosystem itself. And the crates are proudly powered by the amazing Rust community. The Rust community wants you to succeed with Rust, and they are very helpful, a lot more than some other ecosystems and languages that I have been a part of. However, there is one area that the Rust community is trying to improve to get on par with other areas of the language, and that is the GUI. Due to Rust decisions on the language, the GUI is a bit more difficult to implement properly compared to other languages. However, it can and is being used in production. eGUI, a GUI package in Rust, is being used by Amazon Prime to help debug issues. And also the Rust community acknowledges that Rust is a difficult language to learn in the beginning. So they have compiled a large amount of resources, such as books, courses, YouTube tutorials, and the community as well have created a lot of resources that are free to be able to learn Rust quickly and easily. And through the Rustation Nation, we get our own crustacean mascot. Unfortunately, unofficial, however, Ferris is very excited to see you. So you are thinking of using Rust. So what next? How can you start? But naturally, there is a few places that you can help. Firstly, developers. Naturally, as developers, maybe just getting your toes wet will help improve the amount of developers available in Rust. Not as much as there is in other languages. However, according to the 2024 OfferZen study done for South Africa, 14% of people want to use Rust in their everyday jobs. So roughly 3 in 20 want to use Rust every day, and this number has grown since last year. But some of you might say you don't have time to learn Rust. However, we have seen it takes the same time to learn Kotlin as it took to learn Rust. And we also saw that it takes the same time to develop and have the same productivity as Kotlin as it is in Rust. But some of you might have a prejudice against Rust, saying it is a low-level language. Well, true, it is often compared to C and C++. However, we saw it is as readable as Python itself, meaning it can be used in the same applications as other high-level languages. It's exciting and all, but you need more. You need some more proof of why Rust is beneficial to you. You need to see actual benefits. Well, firstly, some of the benefits, as mentioned before, is performance. But not just performance. Performance with stability. And not just performance and stability, but performance, stability, and cost savings. Who doesn't love to save money? According to a blog post, just by switching to Rust, that company saved a theoretical 87% on their operating costs. I don't know about you, but I would rather pay $13,000 versus $100,000 a month on operating costs. And not just that, not just performance, stability, and cost savings, but performance, stability, cost savings, and sleep. Due to Rust being stable, you will get your sleep back. Little to no late night calls, and no worrying if your server has crashed overnight. Now that we have seen some of the actual benefits, you naturally want to start using Rust. I really know that you do. So now you are finally convinced, but how can you use Rust? Where can you start? Well, there are a few ways. With Python, you can use Pyo3 or Rye. A team has used Pyo3 and less than 100 lines of Rust code to improve the performance of Python by 100 times. And not just that, some people have used Rust and Pyo3 to replace packages in the serverless architecture, allowing cold starts to be significantly quicker than just pure Python. Or you can use it with JavaScript, with WebAssembly, or even Neon. Or even Flutter. Why not? You can use Rust and Flutter using Rimph or the Flutter Rust bridge. What about cloud? AWS has officially released version 1 of the SDK towards the end of last year. Unfortunately, Azure and Google Cloud have unofficial SDKs, but it is available and people are already using it in production. Or you can use Tari instead of Electron.js, allowing your code to be a lot more secure, a lot smaller, and a lot more performant as well for native HTML GUIs. Or just you can use it in FFI. You can use it to replace that buggy code or non-performant code with Rust. You can use AI as well. No list these days seems to be incomplete without AI. When Rust provides Candle ML, which was developed by Hugging Face, RustBert for all your NLP use cases, and Burn, another machine learning language. However, with Burn, you can actually change the backend itself. There's also CMake for C and C++ with the Corrosion plugin. I have personally used Corrosion to develop, or to rather migrate, a ray tracing program I wrote several years ago in C and migrated it to Rust. And Corrosion made it a lot simpler and easier for me to do that migration. It generated the bindings for me and linked the packages automatically for me, making my life a lot simpler when I was testing it out. Or you can write custom tooling, such as validating some code or generating code as well, etc. You can use Rust to dip your toes within the language and developing custom tooling for your project. So I have finally inspired you to use Rust. I hope that from today you will consider using Rust a lot more. Thank you for listening to my talk. All the links that I have referenced earlier are available at my GitHub. Thank you.